Hello everybody, good morning. So we'll be going over Catalyst 6500 high availability features in the next 20 minutes. I'm Sudeep Hadiyar, I'm the product manager for Catalyst 6500, and Sean Wargo here is the technical marketing engineer, and we'll be having an actual demo where we'll be going into more specifics. Just want to touch upon the requirements for high availability in the campus core today. Right? Most of the applications that we see are around audio and video. So the time windows that you have for failure are very small. This interesting statistics tells us that for audio it's like 200 to 250 milliseconds, and for video it's even lesser than that. So essentially when we design our systems for high availability, these are the numbers and metrics that we need to adhere to. And this is where the quad soup SSO feature comes in, where we are taking high availability to the next level. So brief introduction about what we are doing here. So how many of you have heard of VSS or, great, okay. So we started off with virtual switching to address high availability as one of the main points there. And we do that today with redundancy across chassis. We have other means such as the warm RPR, which gives us redundancy to some extent, but that still needs, and we need to wait till the switch which has gone down has booted back up. So what we came up with is what Sean likes to call it ultra high availability. So it's not just a marketing term. What we are achieving here is all of the 4 supervisors, 2 in one chassis and 2 in the other, are all hot standby, and they are syncing with each other for all the routing protocols, for all the control plane activities, and essentially making sure that they are all in sync. And we'll go into more specifics of that. But what it helps us achieve is 100% forwarding capacity with any of the supervisors failing. So we've just reduced the probability of any of these going down, and when they do go down, how well do the other ones pick up? So we have something called as an in-chassis standby and a VSS standby, which will make sure that all of this works correctly in case of a failure, right? So the key point there is the automatic recovery. If any of the supervisors go down, we don't want anybody to have to go to the lab, pull it out, put a new one back in, and have effects on network uptime. So this is something that is automated with the different standby mechanisms that I was referring to, right? The local modules stay online every time there is a switchover, and that is achieved by having the in-chassis standby takeover as active and the VSS active takeover on the other switch. So all of that ensures that you have the continuity. What we are achieving with this is high availability, further increase for single attached devices, which essentially means for devices such as workstations and servers, and which are single attached and have only one network interface. The ISM modules are the other part of the story. So that's what we're trying to achieve here. There's just a very high-level summary of this innovation on the high availability side in the 6500 series switch. I will let Sean take it from here. He will go over specifics of each of the different scenarios we're addressing here, and we'll end with an actual live demo. Over to you, Sean.
Thank you, Sudeep. So what I have, and again, we want to go through the slide part of it very quickly. We just kind of want to level set so everyone understands what they're going to see in the demo. In the traditional, oops, we got some cable issues here. In the traditional VSS, you have a different one supervisor in each chassis, and that's fine from an HA perspective. The downstream and the upstream are optimally, they're dual attached. I can full screen it.
Slightly easier.
Better?
Yay!
Yeah.
Okay. And as I was saying, in a perfect world, everything would be dual attached, right? But unfortunately, that can be not cost effective for individual workstations, APs, integrated service modules, as you mentioned, right? And the supervisor in each chassis is responsible for his environmentals, right? So your power, your cooling. So obviously, if you lose that supervisor, then the entire switch goes down. I'm not getting advancement on the. No, it's It's misbehaving.
I
So
think
we're
we'll
just going to
just
do it
stick with
outside
that.
of it.
Yeah.
It gets the point across. So obviously when you lose that primary supervisor, anyone that is single attached to him, unfortunately is off the entire time that the soup is gone. And as well, even those that are dual attached only have 50% of their bandwidth, right? So this is traditional VSS. And then lastly, you know, as Sudeep mentioned, you must send someone out there to physically do this. It's an undeterminate amount of time. You know, it could be an hour, it could be 2 hours a day, who knows? So those are the problems we're trying to solve. Now, Quad Soup just simply brings in 2 supervisors, one in each, and Sudeep sort of gave the short version. So even if the in-chassis active fails, he's able to maintain all the environmentals. So that's what he means when he says 100% availability. Because, and again, this is what you'll see in the demo, you don't see the link flaps, right? In traditional VSS, when I lose this, those links will in fact completely go down. And the neighbor sees this, he won't change his topology, but he does see it, and it does have some impact. So the key difference here is that those modules stay online. All adjacencies are exactly the same. And again, the single attached devices are unaffected. The other point is how traffic is load balanced. It's really only the switch, the specific chassis that's affected that will see a loss. Any traffic traversing the switch that's unaffected gets 0 loss, right? So the net is this 50 to 200 milliseconds, and it depends on the line card because we have additional enhancements with the newer cards to bring it down. It's an interrupt-based fast link notification, if you guys want to look into that.
What's the backwards compatibility? Soup 720 out?
This is Soup 2T
Soup 2T
only.
yeah.
Soup 720 does have quad soup, but it's an RPR based, so it's cold, meaning that the in-chassis standby would have to boot up. So you get rid of that undeterministic. It is automated in that way, but you're still talking 5 minutes, 10 minutes, something like that. So this is 50 to 200 milliseconds, depending on the line cards.
So bear with me a second here.
Sure.
I haven't done anything with the Soup 2Ts, and I haven't done VSS on 6500s, but I've got lots of experience on 6500s
Great.
up through 720s. SSO's been there for a long time. What's the new thing here? I'm missing what's new.
So it's the quad soup element of this. So SSO was switch over at individual switch level or individual feature level
Between the two
between
chassis.
the 2 chassis. Here,
Okay.
what
So
we're
if you
doing
have a single chassis, you've got an active and a standby, and he'll just switch over between the 2 of them. We took that standby supervisor and made him the other chassis. Now you're switching between the 2 of them, but as I said, when the per chassis supervisor fails,
Yep.
that whole chassis is gone, right? This now maintains all of the environmentals of that local chassis. So you have not only an SSO, what we call SSO active and standby between the 2, you've got an in-chassis active and an in-chassis standby.
Okay,
That's
so I wrongly made the assumption that was part of it all along. But again, I haven't touched this, so that's what I was trying to
It was
understand.
Yes.
just within the
And,
chassis, now it's across,
you know,
and you have quad soup.
We actually do have the for Soup 720.
Yeah.
So the new piece is the SSO piece of it.
Okay.
These are statefully synchronized with one another. It's not the RPR based one.
Okay, I think that's what I wasn't getting. Thanks.
Sure.
Great.
All right.
I
So
think
when,
there's a question there.
yes, question.
So is the best case for this like Soup 2T with 68 and 6900 series line cards?
Yes, the best case is Soup 2T with 68 and 69s. In fact, the ultimate is 69.
69 is the latest and greatest in terms of line card features and availability.
Now, you make an interesting point because I wanted to kind of go and show the worst case, which is the 67s, right, that don't have this interrupt-based fast link notification, but still, again, demonstrate what the impact is to the neighbor. So I think it's a good segue. Basically, what I have here, you guys are all more or less familiar with traffic generators, Spire and Ixia, these guys. This is Ixia. It's not super complicated. I have one interface in, one interface out. They're just sending 250 streams to one another, right? Very straightforward. So the red and the green, I don't know if it's easy enough to read, but these are the transmit side and this is the receive side. And you can see the packets incrementing up here. So it's all live, real-time stuff. There's no smoke and mirrors going on here. And then what I have is a 2960S as a downstream neighbor. And what I'll do is a command called show ether channel summary and show that he has a connection here, down at the bottom, between 2 ports. Yep. And then a 3750, same command, and his 2 ports. Now, here in the blue, I actually have 4 tabs, and the 4 tabs are meant to represent the different supervisor consoles, right? So it's literally the 4 soups in the different chassis and what their state is. Now, the whole purpose of VSS is to, as you know, minimize the operational aspects of it, right? Instead of having to go out there and troubleshoot all of these individually, put individual IPs, I just have one system. So there's always just the one interface that I have to deal with. And that, at this moment, is, again, it may be difficult to see, is switch 1, soup 5. And each one of these is named after the supervisor it reflects. So very fast, and I want to show you the new things, to your point. What's something new that I can talk about, right? So we've had VSS, we've had quad soup. Here's the new piece. There's a command called show module switch all. So we already have show module. Show module switch all shows me all the modules in every chassis, right? What's new now, we have the in chassis active, which is this one. And then this second one here. Now it's a little difficult to read, but what you see there is chassis SSO, CSSO. And then likewise on switch 2, he has a in-chassis standby that is, in-chassis active that is standby hot to the other supervisor, and then he has his own chassis SSO. And it demonstrates all the line cards. This is the point I made about having a 6700 card with a CFC, which is actually sort of the worst case for me. So let me show you the ether channels, same as I did on the neighbors. So he has this virtual switch link, which is just between the 2 switches. It's a communications channel and a data channel. But then he has these 2 neighbors. And I just called them 29 and 37 because I'm going to a 3750X and a 2900. Pretty straightforward. Now the other command, which is new, or there are changes in this command, is show switch virtual redundancy. And what this tells you is various redundancy information. In this case, switch 1, slot 5 is the active. And then as I said, the new part, you won't see this anywhere else, is switch 1, slot 6 is the standby hot in the chassis. So this is really the new piece. And then again, the other switch 2, slot 5, he's now the switch over target, right? So that means he's my SSO standby. So it's still traditional VSS, SSO between the 2, but I've also got the in-chassis standby and active. And then again, on switch 2, slot 6, the standby hot chassis. Is everybody good with that? Okay. Again, traffic is flowing. Neighbors are relatively clean. So what I really want you guys to pay attention to is one, the traffic, right? And the reason it may be difficult on the live stream to see, but I've intentionally used transparencies. So even if I have a window up, you can still kind of keep an eye on the traffic in the background. And then keep an eye on what would happen here. Now what I'm going to do is I'm going to really quick shut down a link to show you what happens to the traffic. That's an actual link failure. It's not, quad soup doesn't fix that. If you lose a fiber, you lose a fiber. What multi-chassis ether channel will do is quickly load balance everything over to the remaining link, right? And that's still true. But again, the purpose is to show you what happens from the neighbor's perspective, and again, to show you that it's not smoke and mirrors. So we'll do that very fast. There's a cool command, if you guys are not familiar with it, which is show interface port channel count ether channel. And what it does is it'll show you the whether the traffic is being evenly load balanced. So what I'll do is I'll go in there and I'll just shut down one of the ports. Now, again, with the neighbors in mind and with the traffic in mind of what's going to happen to these. I did 3750. Okay, so the switch both switches, both the local one that I shut down and his neighbor detected that the link went down, right? And you didn't even see a blip because it's 100 milliseconds. Point is, I shut down a link in my path. 100 milliseconds later, it was already on the other path, right? Do no shut, let him come back. Same thing here, the port will come back up. We get link and protocol state. If you guys don't know, the reason you see some of those going up and down is they're going through the link state aspects, and then finally the protocol comes up. So it's like carrier delay, if you guys have looked into these sort of things. So again, everything's back to normal, the way it was, right? So nothing fancy there, just to show you what the impact is to the neighbor. All right, so the real magic, and again, I have these other consoles here, and they're just waiting for something to happen. Normally, you know, the operational staff wouldn't have to worry about these, but if a supervisor fails, you can go out to the other console and handle them. So I will do one more time, show switch virtual redundancy. You guys remember this command from earlier. This switch over target, this is the guy from an SSO perspective that I'm going to actually go to, right? So that means I have to jump over to switch to SUP 5, which is this one.
So we need to think of two switchovers which will happen. One will be across to the VSS active, and the other one will be
Simultaneously, the in-chassis standby.
Simultaneously, you have two failovers happening, which is the beauty of pod soup.
Now, are you guys familiar with the redundancy for switchover command? This is a command that simply instructs the active supervisor to reset, right? That's because I did the no shut.
Yeah.
We do warn you if you've changed the configuration, and then it says, are you really sure that you want to do this, right? So again, you've got the neighbors here. He's clean, right now he's quiet, so this was from earlier. So what we're looking for is nothing to be here, because from his perspective, there was no link flap. And again, the impact to the traffic. So we'll do that. Did you guys watch the traffic in the background? So in the time it took me to, you know, it's obviously going to go through various different things. He's bringing up the protocol state and these things, but all of it's been fully synchronized. And show you the neighbor. As you can see, nothing has changed from the neighbor's perspective. So that in itself is the true magic of it. Traffic is again 100% restored. And what was once, if you look at the console difference, before this said switch 1 standby, he has now come up as the full VSS standby. So this is the in-chassis standby having come up.
Okay, so
This
you've
is
got 3 soup engines sitting there waiting for one to fail.
Yes.
How many can fail at once?
3.
So you can fail 3 soup engines at one time, and it'll be hitless to the 4th.
Well, 1 per chassis. You can ultimately, from the topological perspective, I'll go back to this. From a topological perspective, from the perspective of the neighbors and the clients, which is
Right.
the end result, you can lose up to 3. I can lose all of them in this switch and 1 of them in this switch.
Right.
As long as I have 1 soup still remaining, topologically, the switch is still online.
Okay.
So that's an excellent question. It's the pairing which matters though, but over a period of time, 3 of them could switch. But if your question is simultaneously, how much of them can fail? Then
Yes,
that depends on the
simultaneous.
pairing.
Yeah, you know, obviously, if you give it 3 seconds between failures,
Right.
it should have enough time to recover.
the other- yes.
Recover and go back and forth.
Absolutely.
That's
Yeah,
right.
I'm a huge fan of the worst case scenario.
Yeah, no,
Yes.
that's a good question because simultaneous is the key there.
Yeah.
Thanks for bringing it up.
So, and finally, just to prove that this actually did go down, it wasn't some sort of a fake. If you guys are familiar with the boot up sequence,
Yep.
this switch did completely, or this supervisor did completely reset. And then what will happen is he will come back as the new in-chassis standby, right? So when all is said and done, and again, getting back to the end result of 100% capacity, I always had those dually attached and any single attached I didn't have to really do anything. I didn't have to send someone out there to replace that supervisor, and it ultimately was sub-second conversions. So that's it. Yes, questions?
So what we saw on the traffic, when the traffic dropped behind your translucent
Yes.
terminal session there, right? We saw the traffic drop to 50% and then come back up, and that was during the switchover, right?
Yes.
So this is the fabric channels inside of a switch. It's very similar in that case to a non-VSS, right? And how much time does it take to get from the standby, or excuse me, the active channels to the standby channels? That's the amount of time that's lost. The other part, like I said, is the topological impact, right? That whether the neighbors even see it. But yes, the loss can be interpreted as switching from the in-chassis actives fabric to the in-chassis standby.
Stand by front.
Yes. Does that answer the question? Okay.
Is there any type of preamp for that when it comes back, or do we not care if it's the standby?
We don't care.
We don't care.
Yeah, in fact, that's sort of the magic of it. It doesn't matter which one of these is active at any given time.
And they just figure that out when they come up?
Yeah.
Okay.
Yeah.
Yep.
You talk about the process of upgrading quad SSO?
The price of
Progress
upgrading.
upgrade, yeah.
So there are, one facet obviously is that you will need more supervisors. That's one, and then you just need to move to a newer release. So pretty much you're
Yeah.
looking at
How do we release?
Yeah.
15.1.1 SY1. We can tell you the details. That's a release in which we have support for quad soup SSO.
DSF quad.
So it's free with the purchase of 3 new soup engines.
That's the
Well,
hardware
if
redundancy
you have
aspect.
VSS, you're
Yeah.
anyway
Yeah.
going to have 2.
Correct.
So it's really the extra 2.
Extra two.
On
Sorry,
the
I missed something there, noise or whatever. What I'm really asking is so I own this is my production environment. Now I need to upgrade to a new version of iOS.
yes.
Walk through the process.
Well, you can do an ISSU upgrade anyway, right?
So
So
SSO
at
is
some
not
point you would
impacted
have
if you
these
have a
switches
temporary-
online.
Sorry, go ahead.
SSO is not impacted if you have a version mismatch
No,
temporarily?
no.
Okay.
So for us, it's a much larger discussion,
Yeah.
and I don't know if it's
Yeah.
for here, but because it is an interesting topic, the quad soup actually affects ISSU, since you brought it up. What it is we do it on a per chassis basis, right? So you have switch 1, switch 2. We will bring down switch 2 and bring him back up as version 2. So now you have switch 1 as version 1, switch 2 as version 2. And then you do this run version, which is an SSO over to him. So again, it's SSO between version 1 and version 2. The time, and this is between 100% and 50%. So that's that multi-chassis ether channel. No change in the topology, but the neighbor sees he only has one link. And then you just go through these ultimately. The quad soup is only the time necessary to download any microcode
On
to
the line card.
individual line cards.
Okay.
So that's the beauty of it actually. EFSU utilizes the quad soup infrastructure to make sure that the upgrade happens sooner. So that's the other aspect where we are using all of these 4 supervisors to ensure that your EFSU is actually happening sooner. And the only hit, like Sean mentioned, is for the line cards to come up with the new microcode in the version 2.
Yeah.
But that's the process actually. You upgrade to the new software, you could use EFSU for that, and then that's how you move to utilizing all the 4 quads being hot standby.
And so I think to finish the question, I just bought these brand new soups. I think VSS quad soup is interesting and it's going to be useful for me. When you put those new in-chassis standbys in, if you already have the 15.1.1 SY, it will automatically download that code to him, and he'll just become a part of the VSS.
Yeah.
Good question though actually. Yeah, it actually is a good segue for how EFSU utilizes that infrastructure as well. Yeah.
Well,
Thanks for
traditionally,
bringing it up.
upgrading, especially in a more complex setup like this, is always a challenge.
Of course.
Absolutely, yeah.
Of
You
course.
really
The core
have to
of
have
the-
this.
yeah.
You need to understand the process intimately.
Yes.
What risk you're
Correct.
introducing.
Correct.
And what the impact means
Yes.
and those things, absolutely.
Yeah, and 6500 being in the core, there is a lot of value for all of these high availability pieces. Yeah.
All right, any other questions? Good stuff?
I do have a question.
Yes.
And it's not strictly around your platform, so it's around Nexus.
Okay.
So again, I'm still trying, this makes total sense to me in a high availability environment. We've done
Right.
SSO for a long time. So I'm still trying to wrap my head around the fact that we're just now adding SSO in this architecture. Nexus did this natively out of the box, right? You had SSO between dual soups plus you had VSS.
They don't have VSS. They have VPC,
VPC.
VPC, sorry.
which is still 2 separate chassis. It's a much larger discussion than what we have here, but VSS and VPC are very
different. Yeah, I'm sorry. That was. But
So we have SSO in a single 6500 today,
Absolutely.
forever. Then we, like I said, we took the standby from the standalone and stuck it over here in a second chassis. That creates basic VSS. The point is, these are truly on an infrastructure level, one system. The way in which I program my line cards here is the same as I program.
I get all that. I guess I'm slow. I'm clearly
What is
slow.
the specific
worries.
question? Maybe you can. What is the specific question you had with regards to how this is different from?
Well, I guess I mean if I pull a line card on a 7K in a quad soup environment, I effectively have the same thing. That I've had that for a long time.
Because VPC doesn't do they do a VPC like staple synchronization for pure layer 2. For me, this is layer 2, layer 3. It is one switch.
Okay.
Control plane is actually redundant, and the data plane is
Yeah.
forwarding on both. So
Yeah.
that's the key.
You would have two completely independent switches. I mean,
Switches,
I've used
yes.
different colors here, but for all intents and purposes, there only is this one switch.
One switch because it's all effectively unified.
Completely.
4 switching fabrics.
Yeah.
So
That's
each supervisor is a switching fabric that's forwarding between all of the line cards. Right?
Yes.
Okay.
So with 4 switching fabrics, you've got 160 gigabits per second.
Right.
In marketing speak, or forwarding performance, or 80 gigabits per second. You've got 40, 40, 40,
40, right.
right?
Yeah.
And the idea is that if you flame out, now you can spend. A lot of people deploy 6500s with dual supervisors, right? So that if you lose one, you get a failover and you don't get a reconvergence event. But when you go to VSS, there's no point because it's one switch.
Yes.
The virtual two switches look like one logical unit. So you just put one switch in this. So now you can buy 2 extra supervisors for a very nominal, very cheap price.
Sure.
W performance, which is the pitch, right? This is why you do it. It's the W performance, which also increase your reliability.
Right.
So it's an opportunity to take, strap camels on. Take your camel, your 6500 camel, drop the jetpacks on,
And see how it's
Excellent.
I like the
analogy.
analogies. Yeah.
You can
Well,
take go a
yeah.
little robin and put it in a slingshot, and it'll go really fast.
Are we talking Angry Birds here?
Yeah.
All right, I'm good with that. I'm trying to understand the architecture differences, and again, I'm a little bit out of this by 2 years, but I'm just.
No,
trying
but
to
it's a fair
understand.
question, and I think.
And certainly if we have another field day, which I assume we will, I've seen a lot of you guys before, we're happy to go into the nuts and bolts of what VSS is,
Cool.
Yeah.
those kind of things. And we'll actually be bringing out some new things, but we've been asked to keep this to what we're shipping right now. So this is definitely a big leap for those that are looking at VSS.
So 15.1.1, SY1, and the soup 2Ts is what we need to get all of this up and running. So if you guys have any questions, we can address it offline as well after the session.
Just real quick.
Sure.
What's the difference with the 68 and 69s? Is it the fact that they have the DFCs built in?
Both of them have the DFCs built in.
Right.
Architecturally, the 68s are very similar to the 67s.
Yep.
They are 40 gig attached. They obviously have newer Rev ASICs and these things, but their channels they have 2 times 20, so they're 40 gig attached. The 69s are 2 times 40, so they're 80 gig attached.
Do both the 68 and 69 have the newer Earl chipsets?
Yes, they're both DFC4
Okay.
by default. Yeah. Any other questions? How are we doing on time? We're good?
You guys?
Okay. Well, thank you very much, and that's our demo. Thanks, guys.
Thank you.